Hey everyone, welcome to GrayMatter's emPOWERUP Virtual. It's great to have you here this morning. I have with me today Mark Meisel and Carson Drake, both from GrayMatter. Hey guys, how's it going?
Wonderful, thanks.
Hey Jeremy.
Good to see you. So today we're going to be talking about leveraging AI to manufacture the perfect batch. And we're just going to dive right in today, but we also want to leave some room for questions. If you do have questions throughout today's presentation, go ahead and post them in the chat. If we don't get to them today, we'll get with you afterwards. We can have a deeper discussion. I know a lot of people like to talk offline about projects that they have in the mix. So do use that Q&A function. It's a great part of this platform. So let's get right into it. Carson, the floor is yours.
All right, thanks, Jeremy. But what I thought I'd do is just do a quick little abbreviated version of GrayMatter because it kind of leads into this analytics topic and the perfect batch that we're going to talk about today. So this is my one slide GrayMatter overview that I use often. Talks about the levels of automation and software in manufacturing. And so I'm one of the co-founders of GrayMatter. We started back in 1991 in my basement. And we started off at the control layer. So putting in IBM PCs when PCs arrived and programming PLCs and automation systems and batching systems and historians and so forth. We've probably been in 10,000 manufacturing plants or more at that layer over the last 32 years. And then in the 2000s, we started to get into software above the control layer, performance management software, systems like OEE and quality and manufacturing execution and so forth. We call this the digital manufacturing practice, or I 4.0. And then in the late 2000s, people started to want to Google their assets, Google their processes. And so data started to leave the manufacturing plants and off to things like iPhones and iPads in 2007, 2010. And so as data started to move and remote users started to come in, it became important to protect manufacturing assets. So we created a cybersecurity unit below the firewall for OT. And then over about the last 5 years, we've been into the, manufacturing analytics. I actually had that up here at GrayMatter. And if you think about those systems below level 3, level 2, level 1 systems, those systems create a lot of data. You know, there's a lot of historical data in historians. There's a lot of historical data in OEE and quality systems. And they're good at looking at the past and the present. But what we're doing now is we're working with new and existing customers, and we're connecting to those data systems, and we're using the past to educate and train machine learning models, and then turning those models loose on new data to predict the future, and particularly predict bad things in the future, and giving you advance warning and things that you can do to avoid those bad things from happening. And so we have a process here in the analytics group where for new use cases, we come in, sort of size up the use case, do some data validation, build a template, use pilot or proof of concept or proof of value, work that system into eventually deploying. And that's about a 3-month process typically when we're looking at new use cases. What we're going to talk about today is a use case called the perfect batch, which cuts this time frame down to literally hours. And so when Mark gets into the details of the perfect batch, we're not talking about weeks and months. We're talking about hours, and literally in a day or two delivering super high value content. Mark will talk to you about that content here in just a minute. And so over the years, we've worked with everything, from the plant floor control system layer to the manufacturing execution I 4.0 layer. And so we've obtained partner certifications. We're experts in a lot of different technologies, both hardware, control systems like Rockwell and Siemens and Group Schneider PLCs, and all kinds of different software pieces, different historian companies, different HMIs. We're going to talk particularly about an analytics partner that we have, our premier analytics partner called TwinThread. And so what we're going to go over today is we're going to go over twin thread briefly, and then I'll turn it over to Mark, and he's going to go into the perfect batch. He's going to talk about the application overview, how it is installed and set up, and then what it does, and then finally, and most importantly, driving actions out of it based on what it shows you. How do you operationalize that back down to the plant floor to take advantage of the insights that the application shows you? And literally, this is just a day or two. So Twin Thread, the platform that this is built on, is a digital twin platform. And what it does is it connects to factory floor data systems and quality databases and maintenance management systems and all kinds of different data sources, and brings that data into the cloud and creates a digital twin of not only the equipment, but also the process. And so the work and the magic of this happens in the cloud, and then based on what it learns, and when it's starting to predict the future, it's providing recommendations back down into the plants, and in most cases down into the native interface that the operators and supervisors use to operate their equipment on a day-to-day basis, like your favorite HMI, like GE iFix or Wonderware, or perhaps Pi Vision or whatnot. And then built into the system, there's pre-built applications, things like the perfect quality and perfect uptime and throughput, and manufacturing things that we solve. And we're going to particularly focus on an application that's called the perfect batch. And what this is this is a screenshot of the software where you go in and you pick the use case that you're interested in. Like, you'll see things like throughput and predicting downtime events and predicting quality failures, test failures, those kind of things. And you'll see these two that we've highlighted here called the perfect batch. And there's two flavors of this. There's a ISA S88 version, which connects to out-of-the-box S88 batching systems. Any S88 batching system. Examples of these are Aviva InBatch, the GE Batch system, Rockwell Software's Factory Talk Batch. So it connects to those, or it can connect to custom batch systems. There's a lot of, we call them simple batch, but they're custom batching systems that are more along the line of phase managers or recipe and set point systems that interface down into the control system that way. And so we interface with either type, and literally this is minutes and hours to get this up and running. And so with that, I'd like to turn it over to Mark Meisel, and he's going to step us through what this perfect batch application is all about. Thank you.
Well, hello, everybody, and really thank you for joining us. I think you'll find this interesting. So we're going to talk about the perfect batch application. We're going to do an overview of that, and let's move along. So Twin Thread, as Carson had mentioned, is tightly integrated with your S88 batch systems to analyze all aspects of utilization, throughput, quality, and process control based on configuration and data available in the batch platform and associated historian. The Perfect Batch app is a companion to the Perfect Production app that is tightly integrated with your MES system and used for comprehensive optimization of production processes. The Perfect Batch app is enterprise ready, can connect to many S88 batch servers simultaneously, creating a single consolidated and integrated picture of batch performance across your entire enterprise. Having an integrated and consistent picture of performance means that you can easily identify, prioritize, and execute on continuous improvement initiatives backed by simple but comprehensive analytics and advanced tools to drive collaboration and action. The ultimate goal is to continuously monitor batch performance across the enterprise to provide real-time insights and automated actions that directly improve cycle times, quality, and utilization. In addition, the analytics serve as a foundation for quality, operations, and engineering teams to collaborate around recipe optimization. And so we do give you an enterprise-wide view of performance. This could be multiple plants, lines within a plant, and it is organized in a hierarchical, tough word to say, folks, hierarchical fashion. So it's very easy to identify and understand what you see. And what we're really trying to do is strive for perfect batches. We're looking for overall conformance to the perfect batch profile, which we're going to learn from your history. We're going to understand timing, quality, and we're going to give you a process anomaly score. So let's start first by talking about perfect phases. So an example of an anomaly in mid-phase, we're going to help you evaluate what are the normal curves. So that's everything under or within the green section here, and automatically determine based on your batch history, and then create real-time anomaly scores and their severity. Likewise, we're going to do similar with your cycle times. We're going to help to reduce them, and we're going to illuminate, as you can see in the green area, we're doing great with cycle time. Where it starts to turn red, we're exceeding what we expected in a specific phase or an area of your cycle. And this, around cycle times, here's a detailed look at that and where is the potential for improvement. We're going to rank that potential improvement and not just time. Where there's variability and potential for improvement, could be a manual phase waiting for an operator to do something, operator taking 5 minutes for one batch and 30 minutes on the next, or automated transfer times, filter or pump deteriorating will go higher and higher in the list as the phase starts drifting. Hold times, downtime in the batch process, allocate time, waiting on a resource to come, to become free, and all of this drives continuous improvement initiatives. And so here you can see, perfect addition efficiency. This is where we're adding material to a process and kind of gauging how efficient we are at adding, our materials. We'll also eliminate the perfect yields when we're producing what we expect to produce, and more importantly, when we're not. So here we're seeing in the red here, yield anomalies have been detected and highlighted. Utilization. Where are your bottlenecks? Do you know? Which part of the process are the biggest bottlenecks? Conventional wisdom is the mixer is the bottleneck, but we can see that there is a unit here that is periodically the bottleneck. We'll help illuminate that and, drive you to find ways to solve that. Perfect quality. So drilling into why the score was high or low. Scores for each parameter, material or processing parameter, stack ranking of worst things from ideal that caused the score to be high. Could be an ingredient thing or a processing thing, heating, cooling, vacuum, etc. So this is not difficult to install or set up. And we can move on here. Yep, there we go. So literally it's wizard driven, and we have a launch pad for system configurations, basically the most automated of all the apps that we have. In a typical app, you build out the twin and the dimensions, but since we're basing this on your existing hierarchy and S88 model, we can build this out pretty much automatically. This is another level of automation. You just go through the data source wizard. So like I said, this auto creates everything. So once you point to your S88 system, this will start self-configuring. Performance monitoring. So like we mentioned, we're going to monitor really everything here. We're monitoring utilization, and we're looking for the bottlenecks. We're also going to do performance by batch to batch, comparing them. And we're going to illuminate, timing, quality, process anomalies, and so on. And then the overall conformance to your perfect batch profile. So how are we doing against what we consider to be perfect? So understanding the anomaly scores, the higher the number, the more anomalous it is. Distance from normal. Generally, a number less than 75 is good. Over 100, not so good. For time anomalies, we take into account both the amount of time and how unusual that amount of time is for a given unit, procedure, operation, or phase. For quality anomalies, it takes into account batch data like material additions and process data like agitator speed, for example, and evaluates how far away from normal those parameters are for the given phase. For process anomalies, each process measure is evaluated against the ideal batch profile in real time. Deviations at any point in the phase from the expected ideal range generate these anomalies. We'll look at things like utilization by unit. And you can, hover to highlight a specific unit, click to see a list of batches as they progress through the various units. And then the actual batch time performance. How are we doing, again, batch to batch overall, and are we drifting? See how cycle time relates to hold time and run times. And then we're going to help you optimize your cycle time. So we're going to look at cycle time performance over time, over batches, and understand the trends for each facet of the unit and phase, and help you determine, where you are and how to improve. So understanding timing metrics a little bit, the S88 timing definitions. By the way, this can also relate to the simple recipe management systems, even custom development, as Carson had said, to provide the same sort of context. And, here we're showing you, an explanation of cycle time for batch, unit procedure, run times, hold times, allocation times, idle times. In S88 based systems, this would expose unit procedures, operations, and phases. In custom developed batch systems, only the phases are exposed. Idle time analysis. Well, analogous to blocked or starved conditions in the OEE paradigm. If you're using an MES, that will make a lot of sense to you. But we'll help you understand where you're idle and why. Batch timeline phase level. The green indicates that a phase time is within spec, and red indicates time overruns. Cycle time anomalies, and it just basically it's a ranking by amount of time, how far away from normal something is. So frankly, the shorter, the better. So it's a Pareto of anomalies ranked by time. Cycle time analysis based on identified variability. This will bring to the forefront cycle time improvement opportunities that could have the greatest bottom line improvement. It focuses attention on what matters, analyzing, or rather, here's an analogy. We have another twin thread application, which is called perfect production, which in a similar way exposes downtime issues that have the greatest financial impact and potential for savings. Cycle time distribution, another sort of a Pareto. Over all the batches, what is the shape of the curve? Alerts can be generated based on expected cycle time deviation, like a quality sample phase, for example. Ultimately, you'd like to optimize quality, and that's where we're headed. This is a daily batch summary of the anomalies indicated from a quality perspective. And again, it's a Pareto of your top anomalies, and we're going to score it, and the score indicates how unusual the value is. The higher the number, the more unusual it is. Process optimization, similar to cycle time optimization. Now we're looking at process anomalies by phase. We watch a batch now moving through, batches in real time, and these phases have severe anomalies, the ones that are in red. Here, the ones in green, all phases are operating with, the expected timing. Process anomalies, well, the whole idea is to stay within the green envelope and you'll realize more green. Minute by minute, how well it's following the ideal batch curves or profile. Anomalies produce anomaly triggers that can alert mid-phase or mid-batch, kind of give you some insight before you're making a bad batch. And then the batch timeline, it's literally that. It's a timeline of how your batch is processing through the various phases, and we will illuminate any anomalies in that batch. And all of this leads to, what are we going to do about it? Some driving actions. So now what? What might you do? Is it cycle, quality, or process control anomalies? Are they short? We'll give you a short and a long-term view. The long-term view, potential improvements to prioritize continuous improvement activities. Short-term, drive real-time situational awareness, potentially feedback into controls automatically, and of course, generate alerts. And then we'll help you to alert and troubleshoot, and we'll walk you through how to deal with those alerts. So because we are a thread-based system, threads do drive actions automatically. So threads drive actions automatically, and they execute integration with external systems. We know cycle time is taking too long to the transfer, so trigger maintenance to go and maybe perhaps take a look at a pump. We really would like to thank you for joining us. I think Carson's got a little commercial he'd like to do with you about an event that we're having in about a month.
Yeah, thanks, Mark. So that was a helium version of this perfect batch system. We look forward to some questions here as we go, and then getting together with folks and going through this in more detail. We have just kind of wrap up that part of the webinar here. We have several big companies using it. One of them is a Fortune 100 global consumer packaged goods company. And both on the material savings and on the cycle time, improving capacity, they've had some tremendous results. And we hope to get a chance to work with you all in your facilities. So having said that, Mark, thank you. And we'll open up some questions while we're waiting on the questions to come in. A little commercial here. We have an annual user group conference that we've been doing for 27 some odd years. Up at Put-in-Bay, Ohio. So north of Sandusky, Ohio, in the northern part of the state. Actually, a little ferry ride out into Lake Erie. And what we do is we bring together customers, and a lot of it is customers presenting to customers their cool applications for the year. And then we introduce, best practices, sharing, and new capabilities in existing and new solutions, and wanted to invite you to that. And if you're on this webinar, you get half off on the user conference fee. Just use the code BR549 and you can come right in and get a discount. So with that, Jeremy, let's turn it over to you for facilitating a few questions.
All right, guys, we got a couple of questions coming in. I'm just going to put these on the screen and we can go through these one by one. The first one is, how do you usually get started, with a client when, they're talking about optimizing their batching system? Carson, do you want to take that one?
Yeah, sure. So we usually start off with a briefing where we get together for about an hour and you discuss your batching systems. We ask some questions about the type of batching system that you have and the data sources, and are you having problem with cycle time and materials and yield. And really what we're looking for is, if we solve those problems, how would you operationalize that back down to the factory? That's the most important part, is taking this and taking the insights and getting them back to the folks down in the plant that can do something about those. So we're really big on talking about, what happens at the end first, and then making sure that we can get there.
Yeah, absolutely. Makes sense. So another one we got here, is this cloud-based or on-prem solution?
You want me to take that one, Mark?
Sure.
Okay. So it is a cloud-based solution. TwinThread sits in Microsoft Azure. There is an on-prem portion of it, which is the agent, which connects to the batching system. That typically sits in a very small Windows computer or a VM that's sitting in the plant and has access to connect to the batching systems. And so it's a hybrid with some on-prem agent technology, which buffers and does store and forward and stuff, if there's a need to manage gaps in the internet, but runs in the cloud and then pushes the information. It's all web-based, pushes the information out to the users via web displays.
And just to add to that real quick, for those of you that are cybersecurity concerned, which who isn't, this solution is SOC 2 Type 2 certified.
Good to know. Yeah, I think we all need to have that concern going forward. And if you need to talk to us about cyber, that's something we should get online and discuss separately. So another good one here. So this person's asking, they don't have an S88 batch system. So, does this apply? Does this work for them, Carson?
Yeah, it sure does. It sure does. Takes a few more hours to get it set up because we're deriving the start and the end of the phases and the batch times and stuff from the data, but real quick templated solution for that as well. And it's about half and half with the companies out there that have S88 batching systems or phase managers or recipe managers that they've built themselves. Yep.
Okay. So what does this actually connect to in the plant, guys?
Good question. Good. I see we got some engineers on the phone. So in the case of the S88, it connects to the batch journal, the SQL batch journal. In the case of the simple batch, it'll connect to the PLC or the HMI-based phase manager or recipe management system.
Cool. So when you've had this, up and running, what kind of ROI have you been seeing, for the batch processes? This is a question we always get. This one came in advance.
Awesome. So, one of our customers has seen is working both on the cycle time side and the yield side. In their case, they saw a 10% improvement in overall cycle time and directly impacted capacity. And then the other half of the system was around materials, and they had a 4% savings in yield or increase in yield.
Excellent. So on the user group, do you have to be an existing customer to attend user group at Put and Pay?
Good question. You actually don't. About half of the folks that come to the user group are in evaluation mode and learning about GrayMatter and learning about our customers. And you can definitely get a lot out of, a 20-minute conversation at a conference from an existing customer, as opposed to, lots of slide presentations and demos and sales kind of stuff. So yeah, if you're a new customer evaluating, come on out and work from other customers and see how they're doing.
Yeah, and folks can find more information about the schedule and location and all of that on our website at GrayMatterSystems.com. If you just scroll down from the homepage, it's all right there with the registration. It's also under the events tab, and then also if you check us out on LinkedIn, you can find there. So it looks like we got at least one more question here, and it's about downtime. And we always get this from the engineers too, I think, and the operations guys. So does this require any downtime of the batching system to make this happen?
It does not. It does not require any downtime whatsoever. We're the agent runs on a like I said, a small Windows machine, as long as it has connectivity to the SQL Server batch journal from the S88 systems or to the HMI and historian for the process data. You're good to go.
Awesome. I imagine that'll appeal to some folks for sure to know that. So guys, I think that covers us for questions now. But like I said, if folks have more, we can get with you after and dig in deeper. This was just supposed to be a way for you to find out some of the solutions with batching and what's possible with our system. So Carson, Mark, anything else to add before we wrap up for the day?
Thank you.
Yeah.
Thanks for joining.
Thank you guys for your time. I appreciate it. All right.